From the mind-bending field of neuromorphic engineering to a rare opportunity to view two eclipses, we covered it all in 2023. Now, a recap of the fascinating topics that had us listening and learning through the year. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform. Hello and welcome to Technology Today. I'm Lisa Peña. What a year of discovering and learning from memorable, informative guests. This podcast was created in 2018 as a platform to share the world-changing science and research happening at Southwest Research Institute. That's 5 years of taking you behind the scenes to learn from the scientists, engineers, and tech leaders imagining, creating, and testing new innovations. Now, let's recap our inspiring and intriguing topics of the past year. We launched 2023 with the fascinating emerging field of neuromorphic engineering, the development of biologically inspired technology that emulates the human brain. SWRI engineer and neuroscientist Dr. Stephen Harber, a neuromorphic engineering expert, explained why the brain is a superior computing model.
Okay, so essentially you are building networks, building technology to emulate some of the functions of the human brain. So what is superior about our brains? Why do we want to create technology that functions like the human brain?
Certainly. The human brain is far superior to the ordinary computer, driven by what's called Van Neumann architecture processors, which is what we use today. All our computers use Van Neumann architecture processors today, and our brain is far superior to those processors. CPUs and GPUs, central processing units and graphical processing units, are what you'll find in our computers, and also computing systems and automobiles, self-driving automobiles, aerospace, space. That's our current bread and butter today. And our brain is far better than they are. Now, I know that, those computers, when combined with a lot of GPUs, they can compute numbers fast. But what they're not good at is our brain is better at reasoning, interpreting the outside world, coming up with new ideas, and dealing with the unexpected query. The brain is capable of imagination, for example. The human brain only uses 20 watts of power, which is less than a light bulb, and it has 100 billion neurons. Our memory is co-located with and throughout our brain, where it's not on the current Van Neumann architecture that we use. Our cognition uses parallel computing. Our brains can learn on the fly. Current computers cannot do that. Our brains use asynchronous event-based spikes with sparse information. Our brains are better at learning new things and then changing as required in a new environment. Therefore, in order to improve how our computers currently operate, which they pretty much peaked, so to speak, we need to turn to the human brain as our model and guide and create technology that functions like the human brain.
SWRI's neuromorphic team is currently working on technology for aircraft. Check out episode 51 to hear the entire conversation with Dr. Harber. From building brain-like computers to the building blocks of life, scientists discovered amino acids, the building blocks of life, in meteorites. Amino acids combine to form proteins, which power life on our planet. SWRI astrochemist Dr. Donna Kazum is part of a team that recreated space conditions, forming these seeds of life in a chamber. In February, Kazum explained what the experiment uncovered about the possibility of life elsewhere.
So I like the way you explained that. First of all, calling this material the seeds of life. So you're seeing the seeds of life in asteroids, and that could explain how life sparked on Earth. But another thing you said, this frozen starter kit to life could have expanded to other areas, other solar systems, other parts of space, and so I think that's really interesting that, your big question is, well, if these components sparked life on Earth, could these components also spark life elsewhere?
My heart really, and my passion is to my expertise is really in understanding the chemistry in the interstellar cloud, which is that has that like frozen starter kit to life. And what I find so unique about studying interstellar chemistry is that it is really where everything came from, where our star came from, where the solar systems came from, where the planets came from. And so whatever is found there is kind of like giving us indication that, okay, that those ingredients may be spread out elsewhere as well. And we may not be alone.
So let's get into that. Let's talk more about asteroids and the interstellar cloud. Okay, first of all, what role do asteroids play in the formation of these building blocks of life?
Meteorites, a lot of meteorites. So meteorites are essentially these dust particles that fall through the Earth from space, and they land somewhere on Earth, and people collect them, and they analyze what's in the meteorites, and they find these building blocks of life. And a lot of these meteorites come from asteroids, and they also come from comets.
On episode 52, Dr. Kazem explained recreating the seeds of life in a chamber requires extreme cold conditions coupled with high energy protons. In March, we celebrated Women's History Month with SWRI planetary scientist Dr. Tracy Becker and SWRI engineer Dr. Aaron DiCarlo. They discussed their career achievements and shared their insight on the role of women in STEM, science, technology, engineering, and mathematics. I wanted to ask you about asteroid 26471. Tracy Becker. I don't know many people who have an asteroid named after them. So tell us about that. That had to have been a big moment for you as well.
Yeah, that was very exciting. One of the projects I didn't mention that I work on is also radar observations of asteroids using the Arecibo Observatory in Puerto Rico. And when I was a student, actually an undergraduate student, I went out there for an internship and started working on basically trying to figure out the shape and the orientation of the first known triple near-Earth asteroid system. So this is a asteroid system. It was called SN263. That's somewhat close to the Earth. We pinged it with radar, so we were able to get its speed, just like a police officer's radar is able to know the speed and directionality of a car. We can do that with radar. And so, but we can also get information about what its shape and size and rotation is. And so I worked on this project to understand the primary asteroid, but like I said, it's a triple. So this was an asteroid that had 2 moons, and it was the first one that we knew of that could have 2 moons. And as a result of that work, I kind of have a publication in the field of asteroids early on in my career. And later on, the 2 advisors that I worked for at Arecibo ended up putting my name in for having an asteroid named after me.
Aaron, let's talk more about your outreach in the community as an engineer. Who are you talking to, and what's your message? What are the questions you're getting?
So I think that if I could go back in time and give myself some opportunities, it would be kind of around grad school time. So I do feel like the time that I wish that I had a woman's voice or a woman's insight into how to develop a career and build a network, it would have been during that time. And so I think going forward, that's what I would like to invest time in, is how to reach graduate students and give them the confidence and give them the opportunities to build those networks and build those experiences. And so I think just more direct mentorship.
Episode 53 was packed with personal stories and insight from 2 accomplished women in STEM. On our Earth Day episode in April, we discussed a new SWRI technology targeting rising greenhouse gas emissions. SWRI staff engineer Dr. Graham Conway told us about a novel negative emissions membrane that removes and captures carbon dioxide emitted from vehicles before it escapes into the atmosphere. So what is a negative emissions vehicle? How do you achieve negative emissions?
Yeah, so that's a great question. I know all the listeners remember my podcast when I did it before, word for word, but as a quick refresher, when we talk about emissions in this context, we need to consider all of the sources emissions in the life cycle of the vehicle. So we call a zero emission vehicle a zero emission vehicle because it has no tailpipe and it has no engine, so it is not releasing CO2. However, to make the electricity for some of these vehicles, we do produce CO2. And so by framing things like that, we just need to understand that we need to look at the entire context of the vehicle. When that comes to a negative emissions vehicle, this is a vehicle that, through its use, will have reduced its carbon footprint to the point that by the end of its life, it will have consumed CO2 rather than released it. And it does this by being very careful and clever about the fuel it uses. And also it must store any CO2 it produces itself. And then at the end of it, it needs to bury that CO2 back into the ground.
So is it also capturing any CO2 from the air around it or just its own emissions?
It is capturing CO2 from the air around it, but not directly. So this is the special fuels that we need. So one of those fuels would be ethanol, for example. So ethanol that comes from corn, the CO2 that was in the atmosphere has been absorbed by the plant to grow. And so that's captured some of the CO2. If we just burnt that in the engine and released it again, that's kind of a circular economy. The CO2 just goes round and round and round. But the technology we're looking at will store that CO2 on the vehicle, and then at the end of the life of that fuel tank, we'll release the CO2 underground and store it, hopefully forever.
Dr. Conway gave some great tips about how we can all help lower our carbon footprint. Things like carpooling, planting greenery, and setting your air conditioner higher. It's all in episode 54. In 2023, the Space Foundation inducted NASGRO, Fracture Control Software, and its developers into the Space Technology Hall of Fame, which honors groundbreaking technologies that began as space programs and have since been adapted to improve the quality of life for all of humanity. In May, SWRI NASGRO developers and Hall of Fame inductees Dr. Craig McClung and Joe Cardinal discussed the world-changing software's capabilities. So how does NASGRO keep the public safe? We've talked about it a little bit, but do you have any specific examples of the NASGRO software really shining in the safety department?
Yeah, well, I think the very best news about NASGRO is no news. Nothing's fallen out of the sky recently. When something does fall out of the sky, we get kind of nervous that somebody didn't do their job right. And that's really the compelling story is that the fact that there are not accidents, that there aren't problems, that's good. But more specifically, most of the commercial transport aircraft in the world today are designed and certified using NASGRO somewhere along the way. A few years ago, there were 4 or 5 different regional jets being developed in different countries around the world. Every single one of those regional jet programs were using NASGRO for their design and certification. And so that was kind of a cool feeling. Everything that NASA does, everything that the European Space Agency does, is designed and certified with NASGRO.
And Craig's talking about design of new equipment, new airplanes, new spacecraft, new structures. One of the areas that NASGRO is being used is to analyze and ensure safety of what we all have heard as aging infrastructure. Okay, so we're talking bridges, pipelines, other types of pressure vessels that have existed for 50 years or so. So this whole concept of structural safety, many things that are very old have to be requalified, inspected again for safety.
NASGRO was initially developed to support NASA's space shuttle program, but is now used by companies worldwide to avert danger. Learn more about NASGRO on episode 55. SWRI's microencapsulation experts create custom controlled release capsules for a variety of products. In June, SWRI scientist Dr. James Oxley explained how microencapsulation technology works. So, Jamie, clients worldwide come to you and your team with unique challenges that only microencapsulation can solve. So let's start with a basic understanding of the process. What is microencapsulation and what do microcapsules do?
Sure. Excellent question. Of course, a good place to start. So it's in the name. So it's a capsule first and foremost. So you can think of a space capsule or a tiny drug capsule that you might take. But we're on the micron size. So we're anywhere from below 1 micron, so nanometers, up to hundreds of microns, maybe even a millimeter, so coarse sand down to something you can't see. And they're capsules, so they're containing something. And the most common size might be on the order of tens of microns, about the width of a human hair. And so these are engineered particles where you can have different morphologies, meaning a microcapsule. So that might be, think of a water balloon where you have a liquid inside of a latex shell, but shrink it down to, again, 10, 20, 30 microns, almost too tiny to see. Or you can have a matrix particle or microsphere. And my analogy there is like a ball of chocolate chip cookie dough or a blueberry muffin, and the blueberries or the chocolate chips are the drug or the fragrance or the flavor that you're trying to encapsulate, and then the matrix around that is keeping it into this sphere. And so those are the two morphologies, and when I talk about encapsulation, it's both of those. And the reason to make these types of capsules is to control the release. So you can think about, and we'll talk about carbonless copy paper probably later in the podcast, but if you want to control release of a fragrance, scratch and sniff is a good example. I think we've all had that book where you scratch the blanket or the fruit or something like that and smell it.
Childhood memories.
That's right. And you're controlling that release. And so it doesn't release until your fingernail reaches over it and breaks those capsules. And so plenty of examples that we'll go through, but controlling release is really one of the main functions of encapsulation.
Since 1949, SWRI has tailored this tiny technology for a broad spectrum of industries, including for food, pharmaceutical, cosmetic, agricultural, and biomedical products. Hear more on episode 56. The Engine for Automatic Biomechanical Evaluation, or ENABLE, captures and analyzes 3D motion to help athletes achieve peak performance and avoid injury. Strategically placed cameras and powerful algorithms drive this portable, user-friendly system, eliminating the need for attached movement-restricting sensors. In July, SWRI engineers Ty Templin and Travis Eliason told us ENABLE allows coaches to collect useful data. So, how can understanding biomechanics improve performance? Let's put those two parts together and connect the dots for listeners.
Yeah, absolutely. And this is really the $1 million question, and it's what we get really excited about researching and pursuing. So our group has been developing this technology ENABLE for the last 6 or 7 years, and it's finally at a point where we can start to answer that type of question. So the basic process for understanding performance currently is identifying what the best performers in the world do, that sub-elite performers don't do very well. And then we can provide feedback or training that can help narrow that gap. So we're also pursuing other avenues other than just comparison between individuals that will provide more information for specific applications to improve your performance, but I think we'll jump into a little bit of that later on.
Just a follow-on to that is what makes what we're providing different than what a traditional coach would provide is we're adding that quantification factor. So what I mean by that is we're adding the math and the numbers we're trying to quantify what that coach's gut is telling them. A coach is naturally looking for all the same things that we're looking for. They just have an instinctual understanding of what good motion looks like. We're just trying to put the numbers so we can quantify. So instead of a coach saying, hey, your shoulder was externally rotated a little bit too much that time, we can actually put numbers on it and they say, hey, you were 5 degrees out. Coach can then use that, give that feedback to their player, and then track their performance to see how they're incorporating that feedback they're getting from the coach. So ultimately, we're not replacing the coach. We're just giving the coaches the tools and the data they need to be even more effective in their training.
Beyond sports, Enable has the potential to be a useful tool for healthcare and military applications. Hear more about Enable on episode 57. The Texas Manufacturing Assistance Center, or TMAC, at SWRI supports manufacturers with the tools for success, including training and workforce development. In August, SWRI Senior Program Manager and TMAC Regional Director Bill Rafferty told us about the center's impact on changing the perception of manufacturing work. What are some challenges in manufacturing today?
You know, the number one thing that I hear from our customers is really the challenge to acquire and retain talent. One of the things that manufacturing kind of struggles with is kind of a negative stigmatism about being a dull and dirty profession. But really, it's lots of opportunity for young people because of all the new tools. You think of all the technologies, robotics, automation, software, et cetera. Really is great opportunities for production to increase its efficiency, and really an opportunity for young people to get involved, use their talents, their problem-solving skills, and really forge really great and fantastic careers for both themselves and their family down the line.
So it's not just about being stuck in a factory all day. There's so much more to it.
Yeah, no, you think of some of those old images of factories with steam and grime, and there are some still remaining factories that are hot, but for the most part, there's great opportunities with air conditioning. Some of the user interfaces are very similar to your phone. That's how you control a robot. Yes, there's I think the education system has been a little too highly focused on the 4-year degree. So there has been a shift recognizing the need for, career and technical education and that talent to serve manufacturers. So again, there's just a lot of job openings right now and you can step in without any experience. If you want to work hard, there's great opportunity. And I'll digress for a second, a little story, but it's one of the professions that you can step in without any skills, willing to work as the lowest level assembler, but maybe retire as a plant manager.
TMAC also helps companies update processes and integrate new technologies such as robotics and software into production lines. You can learn more about TMAC's services on episode 58. When we interviewed SWRI solar astrophysicist Dr. Amir Caspi in September, we were awaiting the October annular eclipse that passed through a swath of the U.S. and looking ahead to an upcoming total eclipse in April 2024. Along with discussing eclipse safety and his eclipse-chasing adventures, Dr. Caspi told us why you don't want to miss your chance to see the total eclipse.
Huge opportunity to see a total eclipse. And again, that's coming up in April. For those of us who are not scientists, it's just going to be neat to see. So would you suggest making a special trip just to see the eclipses that are coming up, or at least the total eclipse?
I would definitely recommend trying your hardest to see the total eclipse. If you live anywhere within an easy driving distance of somewhere you can see the total eclipse, it's something that I would absolutely recommend. For most people, seeing an eclipse is difficult because you usually have to travel to some very remote location. It can be very expensive, very time consuming. This eclipse is special because it crosses over so much highly populated and easy to access land in the United States and in Mexico and in Canada. If you can travel to see it, I really, really would strongly recommend it. You can get multiple minutes, 3.5 to 4.5 minutes of this transcendental, transformative experience. And if you can't travel to see it, if you don't have the time, if maybe it's just too expensive to go travel to see it, if you have to be at your job, you will be able to observe the eclipse on TV, online. I really recommend, even if you can't make it, to see it with your own eyes, to engage with the eclipse in some way on the day.
It's such a rare opportunity. And, for some, it's a once in a lifetime opportunity. We won't see the next total solar eclipse in the contiguous United States until August 2044. So you don't want to miss this opportunity.
That's right. I think if you can make it, you will not regret it.
Dr. Caspi is leading 2 eclipse research missions. The project teams will capture images of the 2024 total eclipse from land and sky. It's all in episode 59. SWRI hosted its first Global Decarbonized Mobility Summit, an opportunity for transportation industry members worldwide to convene in one place and discuss sustainable mobility solutions for all types of transportation. In October, SWRI engineer and summit organizer Chris Bitsis shared why the summit was an important gathering for everyone on the planet. So if you figure out the transportation part of this puzzle, you're able to make a pretty good-sized dent in the problem.
Yeah, exactly. And a lot of our technologies are related to those other industries like agriculture or building or electricity. And so we'll even have a little bit of discussion at the summit where we talk about those related technologies. Stationary power, and a lot of those use generators with engines. They also work on power plants. So some of the technology that we look at for reducing or mitigating CO2 emissions does actually share between the transportation and other sectors. But for the most part, transportation is fairly unique in that it is quite different and varied across industries, regions, and transportation modes.
The summit really is of interest to all of us, whether we are in the transportation industry or not. So tell us, again, why is this a pivotal gathering for really all people and the environment?
Yeah, so the importance of the summit really cannot be understated. We have to mitigate these greenhouse gas emissions. And for the last several years, there's been plans and action plans that have come out, and frankly, we're missing those, not just as a country, but as a global entity. And so, whether the plan is wrong or not is one thing, but I think what we really need are more options on the table. That's the biggest learning from studying a lot of these plans and current technologies and pathways is that, frankly, we may not have enough pathways to get there. And the idea with the summit is we get together and we understand where are some more opportunities for improvement that we can build our research around.
Bitsis tells us the gathering, which took place from November 13th through 17th, truly was global, with attendees from China, Japan, Sweden, Germany, and other countries. Hear more about the summit in episode 60. This year, SWRI picked up its 52nd R&D 100 award with the Wideband Conformal Continuous Slot Antenna Array. SWRI engineer Patrick Seamson told us about the antenna's unique features that make it a world-changing, revolutionary technology. So, ideally, as you said, all antennas would be placed way up high on the mast. But yes, this antenna stands out because it can be placed lower on the mast, not taking up that valuable real estate.
The fact that this antenna can be built around a mast and allow other antennas, other systems, again, whether it be a navigation light or even a lightning rod, to still be mounted above it is the significance of it.
And although it's not at the very top, it's still reliable, still powerful.
It's still reliable. It's still in an area where it doesn't get any blockage from the rest of the ship. So it's high enough above the superstructure of the ship.
Okay, so we're going to get a little bit into the electromagnetic spectrum. That may be a new term for some of our listeners. But the antenna operates in the ultra high and super high frequency bands of the electromagnetic spectrum. Why is it important to be able to reach those higher frequencies?
Because those are signals of interest that for intelligence purposes, they're starting to operate in those bands. So you got to, it's like cat and mouse game.
Yeah. And by them, we're talking about the enemy.
It could be the enemy. It could be, it could be whatever. Whatever your purpose for
if it's for law enforcement, then
law enforcement's another one. Yes.
Yeah. Okay. This particular antenna has to be able to collect those signals in those higher frequencies because that's the trend. That's where things are going.
Correct.
The SWRI antenna development team was honored at the R&D 100 Awards in Coronado, California on November 16th. Learn more about the award-winning antenna on episode 61. And that wraps up another year of SWRI's Technology Today podcast. I hope you enjoyed this 2023 recap. You can hear all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, formerly Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Peña, wishing you a happy new year, and thanks for listening.